Mechanism of breathing. It involves two steps, inhalation and exhalation. Inhalation is also called inspiration, exhalation also called expiration. During inhalation and exhalation, the respiratory parts undergo certain changes. Mainly, we observe the changes in ribs, diaphragm, as well as the structure of the lungs. During inhalation, the inhalation begins with the normal position of the diaphragm changing it to contracted state. The contraction of diaphragm causes shortening of its structure, with which it becomes straight and pulled down. As a result, the volume of chest cavity increases. At the same time, the air pressure inside the lungs decreases, whereas the air pressure outside the body increases. It is comparatively more than the air pressure in the lungs. So, the air from outside passes through the trachea, bronchi, and it enters into the lungs. The lungs are gradually expanded. Immediately, it is followed by exhalation. During exhalation, the diaphragm from its contracted state, it moves to relaxed state. So the contracted diaphragm, when it turns into relaxed state, it gets its original shape, that is dome shape. As a result, the volume of the chest cavity decreases. This decrease of volume of chest cavity comprises the lungs. As a result, the air pressure inside the lungs increases, and the air after exchange of gases passes from the alveolus into the bronchioles, bronchioles to bronchus, bronchus to trachea, trachea to larynx, larynx to pharynx, nasal cavity and nostrils, and through the external layers, the air with the carbon dioxide moves. So for the entire process, it takes nearly 2 to 3 minutes, 2 to 3 seconds, In 1 minute, a person breathes 16 to 18 times, and it is totally dependent upon the movement of diaphragm. To some extent in women, even the movement of ribs. Ribs also play an important role in the respiratory movements. The ribs are connected through two types of muscles, which are called intercostal muscles. The intercostal muscles are arranged in such a way, muscles attached diagonally, which are called external intercostal muscles, and another strip of muscles attached in the diagonal form in opposite side to the internal walls of the ribs. When the external intercostal muscles relax, the internal intercostal muscles contracts. When the internal intercostal muscles relax, the external intercostal muscles are contracted. As a result, the movement of ribs takes place outward and inward. So, when the inward movement of ribs occur and when the outward movement of ribs occur. When the diaphragm contracts and gets the flat state, at the same time, the external intercostal muscles contract and internal intercostal muscles relax. As a result, the ribs move upward and also they move outward. This further increases the volume of chest cavity. So when the volume of chest cavity increases, the air pressure inside the lungs decreases, and air moves from nostrils through the respiratory pathway and filled inside the alveolus. from the contracted state to the relaxed state. This is followed by exhalation. Immediately, the external intercostal muscles relax and internal intercostal muscles contract. This makes the ribs in inward movement and downward movement. This decreases the volume of chest cavity. As a result, the air pressure in the lungs increases and the exchanged air passes through the respiratory pathway and comes out. So this process is called breathing mechanism. When the air, during the inhalation, when the air is filled inside the air sacs, the exchange of gases takes place in the air sacs. Air sacs are considered as the units of lungs because lungs, apart from pleura, it does not contain any organs except alveoli. Now let us see the structure of alveolus. The alveolus is made up of single epithelial cells. Here and there they are supported by smooth muscle. This provision of smooth muscle in the walls of the alveoli will provide that elasticity and spongy nature to the lungs, and they promote contraction and relaxation of the air sacs. They are richly supplied with the blood capillaries, and they have the blood flow from the heart, which is a deoxygenated blood, and carries away the oxygenated blood. So each alveolus receives a blood capillary which is supplying the deoxygenated blood and collecting out the oxygenated blood. Their number is numerous, around 300 million per lungs, and they are also folded, elastic in nature, single-celled structures and lined with blood capillaries. All these features helps the alveoli in gaseous exchange. During inhalation, when air passes into the alveolus, from the air, the oxygen diffuses into the blood capillary. At the same time, the carbon deoxygenated blood, which is rich in carbon dioxide, it passes out the it diffuses out the carbon dioxide into the air. This is nothing but exchange of only oxygen and carbon dioxide. How does only these two gases will get exchanged? Why not the other gases? This gaseous exchange depends upon the partial pressure. What is meant by partial pressure? Air is a mixture of gases. Air consists of 78% nitrogen and 21% is oxygen, and other rest of the gases are like neon, krypton, hydrogen. They are all very minimum quantities. 0.04%, which is meager. So as per their quantity in the air, in the total air, each gas exerts its own pressure. The total air pressure at sea level is 760 Hg per mm. This is the total partial pressure of all the components of gases of air. So when you come to the oxygen, it exerts its pressure approximately 150 mm per Hg. Similarly, the carbon dioxide it exhibits nearly 0.4 mm per Hg. So when the atmospheric air enters into the alveolus, the partial pressure of oxygen in the air is more compared to the carbon dioxide. Whereas the partial pressure of carbon dioxide in deoxygenated blood is more when compared to the air. So as a result, the oxygen which is more in air, it enters into the blood, and the carbon dioxide which is more in the blood capillaries diffuses into the air. Never nitrogen exchanged, because the partial pressure of nitrogen is very high, but it is not a component of blood, and moreover it cannot dissolve in the plasma or into the RBC. That's why the nitrogen is never being exchanged in the alveolus. So air, after collecting the carbon dioxide, passes through the alveolar ducts, then to the bronchioles, then to the bronchus, then trachea, larynx, and even through the nasal cavity through nostrils it passes out. The exhaled air also contains some amount of water vapor. When you blow the air on the mirror, you feel the mirror will become blurred. This is because of the water vapor which condenses on the mirror. This indicates the exhaled air also contains some water vapor. This water vapor is produced as a byproduct of cellular respiration, which has been exchanged out. Partial pressure helps in exchange of gases here. From the 21% of oxygen, only 5% will diffuses into the blood, and the exhaled air contains 16% of oxygen. This is because of the ability of hemoglobin, which can transport at a time only 4 atoms of oxygen, 4 molecules of oxygen. And the carbon dioxide in the exhaled air is 0.4%. The exhaled air consists of 16% of oxygen. Means out of 21% of oxygen present in atmospheric air, only 5% is exchanged and rest of 16% is exhaled out. Whereas the carbon dioxide, which is 0.04% in the atmospheric air, but the exhaled air consists of 4.4%. So this 4% of air, it is carbon dioxide, is added as a product of cellular respiration to the exchanged air. The efficiency of solubility of oxygen or transport of oxygen by the blood, it depends upon the hemoglobin saturation. The at a time can carry only the 4 atoms of oxygen at the sea level. But however, the amount of oxygen differs from place to place. That's why only 16% is expelled out, only 5% is dissolved or diffused into the blood. Such blood, after absorbing the oxygen, is known as oxygenated blood. So, in the lungs, the oxygenation of blood takes place. Oxygenation is different from oxidation. The blood is added with oxygen. Oxidation means addition of oxygen to another atom or to another molecule. That is a different process. That is oxidation. So the deoxygenated blood is converted into oxygenated blood. So how deoxygenated is converted into oxygenated? First of all, from the deoxygenated blood, the carbon dioxide is separated and oxygen is added. Such blood is known as oxygenated blood. So all these veins, they join and carry the oxygenated blood to the heart. And the left ventricle of the heart receives the oxygenated blood, from where it is circulated through the left ventricle to all the body parts. Now the third step of the respiration. Transport of gases. Blood is the chief carrier of gases. In blood, the red blood cells and plasma will help in transport of these gases. The blood which passes to the lungs is deoxygenated blood, which consists of the hemoglobin binded with carbon dioxide. Now let us know about the hemoglobin. Each hemoglobin molecule consists of 4 empty bonds which can be readily combined with either oxygen or with carbon dioxide. But the combining capacity of hemoglobin either with carbon dioxide or oxygen depends upon the partial pressure. Means it again depends upon the amount of oxygen and carbon dioxide either in the atmosphere or in the blood. The deoxygenated blood which reaches the lungs consists of high partial pressure of carbon dioxide and low partial pressure of oxygen. This enables the hemoglobin to lose the carbon dioxide to the atmospheric air and diffusion of oxygen. So, the hemoglobin will be bonded with oxygen. To bind with all the 4 bonds of hemoglobin with oxygen, the oxygen must be in atmosphere at least 21%. If suppose the amount of oxygen at sea level only maintain 21%, but sometimes if we are moving to the higher altitudes, as the altitudes increases, the atmospheric pressure decreases. As a result, the amount of oxygen in the air also decreases. If the amount of oxygen decreases, the partial pressure of oxygen means the dissolving ability of oxygen into the blood also decreases. At that moment, all the 4 bonds may not be occupied by the oxygen and the hemoglobin of RBC may carry less oxygen along with it. This is one of the reasons while we are moving uphill, we feel suffocated, breathless, and to some extent we breathe vigorously also to get the sufficient oxygen. First of all, when you are going on uphill, you are moving away from the gravitational force. So, when you are moving away from the gravitational force, you have to apply more energy to lift your body away from the gravitational force. So, the energy expenditure is more, which demands more amount of oxygen. But as you are moving uphill, the amount of oxygen in the air also decreases and the capability of hemoglobin to carry the oxygen, to transport the oxygen to the cells also decreases. That's why people who will go to the mountain peaks and all for climbing, they carry the oxygen cylinders along with them. But the same point is reversed by the divers. The sea divers, when they dive into the sea water and great depths, they also carry oxygen cylinder. Is the reason is same? No. Our lungs are designed to breathe only in the atmospheric air. That means our lungs can absorb the oxygen which is found in the gaseous state, that is in the air. But when we dive into the water, the oxygen is in dissolved state in the water, which our lungs cannot absorb. So like fishes, we should have gills to breathe in water. But with lungs, we cannot breathe in water. That's why the sea diver carries the oxygen cylinder to go into the water. So when the blood flows through the lungs, the blood is oxygenated because of high partial pressure of oxygen in the lungs and low partial pressure of oxygen in the blood. And carbon dioxide is exchanged to the lungs because the deoxygenated blood partial pressure of carbon dioxide is high, so it gives out carbon dioxide here. Such blood is called oxygenated blood. The oxygenated blood is transported through the blood to the different cells. Imagine this is a tissue. These are the cells. The cells continuously uses oxygen and oxidize the food. As I already explained, the oxidation of food helps in the formation of carbon dioxide and water along with the energy. This is only called cellular respiration. So due to the cellular respiration inside the cells, the carbon dioxide is converted into the oxygen is converted into carbon dioxide. The carbon dioxide and the water vapor, which are the byproducts of respiration, they are ready in the cells. The oxygenated blood, when reaches the tissues, the partial pressure of oxygen in the blood is more, whereas in the cells is less. So the oxygen diffuses into the cells. The partial pressure of carbon dioxide in the cells is more and in the blood is less. So the carbon dioxide diffuses out of the cells into the blood vessels. This is nothing but the exchange of gases at a tissue level, which is the fourth step of respiration. I will once again repeat. The deoxygenated blood from the body parts is brought to the respiratory organs. The respiratory organ consists of atmospheric air. The atmospheric air consists of high oxygen levels and low carbon dioxide level. Due to the variation in the partial pressure of oxygen in the deoxygenated blood and the lungs, the oxygen is absorbed by the blood and carbon dioxide is given to the respiratory organs. The blood is oxygenated. The blood is transported to the tissues. In tissues, as a result of cellular respiration, the oxidation of food results in the formation of carbon dioxide, water and energy. The byproducts of respiration, carbon dioxide and water, are ready for exchange. When the oxygenated blood flows close to the cells which are carrying high carbon dioxide with more partial pressure exchanges the carbon dioxide and takes the oxygen. The oxygen diffuses into the cell because the partial pressure of oxygen in the blood is high. So as a result, the oxygenated blood is converted into deoxygenated blood, which is again brought back to the respiratory system and gets oxygenated. This process continuously happens in between the respiratory system and the tissues as long as the respiration process continues. Of respiration is called cellular respiration, which takes place inside the cells. Respiration.